Hello. Let me know if you can hear me. Okay. Well, let's get started. Hopefully the sound is okay. I'm gonna be using my new settings for the live stream, so I'm not sure if the sound is okay. Hopefully it is. Well, let's just start doing it. Okay, thank you for the comments. Okay, so today, so this is a Houdini tutorial live stream called Houdini Algorithmic Live, and this is 151st episode. The theme for today is to create this swirl curly folds-like sculpture using Houdini with vellum, a physics simulation system in SOP context. Okay. So, and I would like to create this kind of a 3D like sculpture, but using more of a 2D physics engines, physics simulations to achieve this. And what you could, by changing the parameters, you could try out different shapes from different profile from the basic curve. So I think will be interesting. I got the inspiration from this post on Pinterest. There are a bunch of sculptures like these while I was searching for interesting shapes, and yeah, I thought this kind of shape is pretty interesting. And I was wondering how I could kind of recreate this kind of a feeling or organic looking shape using Houdini, and I came up with one solutions using vellum, using a physics simulation method. So I'll show you how I did this. Right. So the basic idea is I'll just show you my examples that I created. The basic idea, first of all, create a simple curve as a profile, create a bunch of layers like these, and should be laid on top of the 2D plane, in this case XZ plane. And I am going to use a hair constraints for vellum, which often used for obviously a hair or ropes, strings, and so on. But instead of using for a hairs, I'm using it for these curves. And each curves will be converted into a hair constraints, and I'm also setting some goals for the final scale for each strings. So meaning that I'm going to scale it up over time, and as a result, what you get is from this curve to these curve, which seems like it's each of the curve is growing over time and pushes over to create this kind of profile in the end. Now after that, I'm taking the trail for all the curves that's been created, then creates a lofted geometry over all of these curves like these. Then to make it a bit more, to make it a little bit looks similar to what I was referencing to, like these ones, I'm making a profile more like a mountain-like shape from the starting point to the end point, I wanted to make it a bit more mountain-like shape, meaning the starting point have small height, on the middle you have the highest height, and on the end you have again a smallest height. So wanted to trim this surface like a mountain. So what I did is trimming a surface using some technique using clip. I'll show you later. Then that's pretty much it. All you just need to do after this is just applying some materials to create some neat look. Okay, so that's my process, and let's try doing this from scratch, shall we? As always, you probably learn the basics of like vellum, as well as how you can change some basic constraints for the vellum using Vex, as well as some trimming technique using clip in order to achieve the one that I just show you. Okay, so start, create a geometry node from scratch, and let's see. I'm going to create a simple curve first on the XZ plane first. So let's use curve polygon. Okay, let's make sure to save it every time I change files so that I don't lose the process. So change this to show handle mode so that I can click on top of the plane to draw some curves. Let's try making some S-shape curve like this. Okay, now this is a bit too blocky right now, so let's make this a bit smoother by first of all using a resample node. And I'll keep the length to 0.1 for now. I am going to change the tree polygon as to subdivision curve, so it'll be smoother like that. Looks good for the first profile. Then to make it short, it becomes a bit more smoother, I'll also apply some smoothness, which is not really necessary but might be good in some case. Doesn't really change much. It's not really important for this one. Now I'm also, since I would like to have an array of curves like on the perpendicular directions to be used as a layer, so in order to have that I would need a perpendicular direction info for each point, which you could kind of get related to that information using orientation along curve, which gives you a tangent vector as an n attribute. So if you show the normal directions, you see the tangent vectors showing up on each point as an attribute, which could be rotated 90 degrees to get the perpendicular directions. All right. Next, so let's create some offsetted layers from this single curve using for each number loop, defining how many layers you want. I mean, I could go with 10 for now, maybe. Then let's create some point wrangle to offset each of the point on this curve based on a iteration number coming from this meta node. So connect this here. Let's call this offset. Get the iteration value detail, which goes from 0 to the number of iterations, so from 0 to 9. So I want to convert this into a normalized value to be able to use it and to be able to use it more in a useful way, meaning normalize it. So let's call this t, which is a iterations divided by the number of iterations, which you can also get as a detail attribute like this. Now this is the number of iterations is actually 10, but the final number for the iterations is actually 9 because it starts from 0. So to make it 9, I'm going to subtract by 1. I'm going to subtract the number of iterations by 1 so that it will be 9. And as a result, you get a value in between 0 to 1 as a t variable here. Okay, and I'm also going to offset this by 0.5, subtract this by 0.5, so that the range will be negative 0.5 to positive 0.5. Right. Now, let's get the perpendicular directions for each point and use these values to move those points on the perpendicular directions. So first of all, let's get the normal direction, the tangent direction, which is an attribute which you have created using orientation along curve. Okay, now let's go back to the point wrangle, and what we want to do is to rotate this to 90 degrees so that you can get the perpendicular direction. So what I always do is to create a rotation matrix which rotates the vector by 90 degrees, starting with by creating identity matrix, then rotate it by 90 degrees using y-axis. Then the identity matrix will be converted into a rotational matrix. After that, you could multiply vector with the rotational matrix to actually rotate the tangent vector. So let's check if we are getting the right value. It looks good. So I have just replaced the normal directions to perpendicular directions, and that which looks correct. Now let's use this directional vector value to offset these curves based on this t value. Also, I want to make sure that the starting point and end point doesn't offset that much, but on the middle you get higher offsets, meaning you want to make something more of a mountain-like shape for offset. So let's create an offset value. You could, there are pretty much a lot of ways to create such mountain-like values, but the easiest way is to use sine wave with the range between 0 to 180 degrees, which I tends to do a lot of time. Now, in order to create the value, you would need the value in between, the value from starting point to the end point, which corresponds as the position of the point. Could be from 0 to 1. Currently I only have a point number which could be used, but might be better if you go back to resample node and turn on curve view, which will create a value in between 0 to 1 from start point to the end point. You might want to avoid using point numbers because sometimes it could be shuffled. It could be in the wrong order might not be on the order from start to the end in terms of the point number, so I would avoid using it. Okay, so since we have that value, we could then use that attribute for the point, put it inside the sine functions and multiply it by pi, so that the pi means 180 degrees, so that the value will be in between 0 in the starting point and pi on the end point, and in the middle will be something pi multiplied 0.5, which is 90 degrees. Now as a result, you get more like a mountain-like values, go from 0 to 1 to 0. So let's check that. I'm going to offset the point to the perpendicular directions, multiply by offset, and also multiply by t, which also which is defining the amount of offset for each layer. Okay, let's hide the normal. Now it looks a bit thick, so let's also have some parameters to control the thickness of overall layer. And I might want to have some space in the first point and the end point, because in the end I am going to apply a vellum like physics simulations. So if the point is touching to each other, it might not create a better result. So I think I would need some spaces in between these points. So let's give some points, and in order to do that, I might need to change somewhere around here offset. So offset is using sine curve, which gives you the value in between 0 to 1, but maybe I can make it 0.1 to 1.0 to have a bit of space in between the curve. Well, I might need to increase the space later, but let's just go with this for now. Okay, so overall, I'm fine with the initial profile for the curve. Now let's go to the next step, setting up a vellum constraint from these curve. Okay, so first thing first, I am going to look for the vellum constraints, and first of all I do want to pin the starting points of each curve and the end points of each curve, so it does not move from that positions. So in order to make the end and the starting point to pin, the first thing I need is to set some group to those start and end points. So I'll do that using point wrangle for ease. Okay, so maybe using primitive wrangle might be easier. So let's get the list of points from the primitive, and before doing that I might want to make sure that the points are sorted based on the vertex order, so that the first point of the primitive points is always the starting point, and the end points of the primitive points are always the end points. Okay, this is just a safe, make it safe. I don't think you would need it in this context, but you might want to have it if you're getting curves from somewhere else. I got a comment, why not just group by range, quick and easy? Maybe But I do know that I can group the points for the first points like this. Just set the set this to 0 and then name it to pin. You could pin the first points. Or is this one? Yeah. Oh, although I cannot do it here because it's separate primitive, so maybe let's do it here. Okay, and for the endpoints I do need to count the points, so maybe I could just, I don't know, sort, reverse the sort the point and do the same grouping again so that I can have 2 pinned point. That's also fine, I think. Do we have it? Seems like I only have one. Not sure why. Is it overriding? Maybe. Wait. What did I do wrong here? So the order 0. So this has been grouped. Oh. I see. And this has been grouped. Didn't realize that it's just going to okay, not replace but union with existing. Okay, should work. So I have 2 points. Now, yeah, the method doesn't really matter how you create the group. Thanks for the tip. Sorry, group by range. Sorry, maybe I haven't really used this one before. So it has, okay, looks useful. Let me see how it works. Okay, it's learning by trying it. Let's see. So, okay. All right. So this also works and much easier. Thanks. Thank you. Yeah. I'll just keep it here. And if you look into the connectivity tab, it lets you do it per prim. Okay. Useful. Very useful. Thank you. All right. Okay. I think we're all set here. We have a pin group on the point, starting point and end point. Okay. Now, next, I am going to create a vellum constraints for the pin. And there are no default pin, so let's create a vellum constraints. Connect the curve, then set it to point and select the pin so that the pin points will not move with these simulations. They'll always be fixed in that position no matter what. All right. Next, I'm going to create a vellum hair constraints. Okay, connect all these 3 inputs to, and I'll set up some stuff here in order to define, especially for the bending stiffness. The stretch is fine, it's pretty strong enough. Stretch constraints is fine. For the bending, I might want to make it a little bit bigger, so that it will bend. It will be a bit more stiffer. It bends more like a rubber, and so on. Currently 0.01. I think it's a bit 0.01 is a bit too weak. So let's try with 0.1 for now. I'll come back this later to coordinate. Okay. Other than that, I think it's fine. Now, next, what I want to do is to control the scale of these strings over time, so that it will grow over time. So what I want to set up here is the final like scaling value for each curves. Okay, so what I would do, I am going to give some additional informations to a constraints as a primitive right here. Give some goal scale for simulations. Now, how do we calculate it? How do we calculate that? Now, let's see. You could just set the same scale for every curve, but what I found out work best to get the similar results that I saw in the the Pinterest, is to scale the outer curves bigger and make the inner curve smaller. Make the inner curve scale smaller, like 1 or even 0.7 or something. So to do that, I am going to pick the primitive number, then you convert that primitive number into a scale value, going from bigger value to the small value and then go back to the bigger value, which is another mountain-like value, so you could use a sine again. Okay, so one thing you need to be careful is that when you are converting when you are giving some informations to a constraints, it's all converted into line. Like the stretch value is all being converted into line, so it's not anymore a one continuous primitive. So actually you do need to get the informations from the first input, which is a shape itself. What you see from the second input is just the constraints preview, which looks like original geometry, but it's actually no, it's just a constraints information. And the original geometry is actually this one, which you have 10 curves. So you do need this information here. So I'm going to connect the first input to the second input of this primitive wrangle, and what I want to get is a closest primitive number from each line, each constraint line, and I would only need to set the scale for the stretch constraints. So I'm going to filter it by stretch, then try to find the closest curve from the second input, which I can use a XYZ distance function, which gives you a closest primitive number. So you can just use that primitive number to convert it into a mountain value, mountain-like value. And you also might want to know the number of primitives from the second input, so that you can normalize the value. Okay, so the normalized value will be prim divided by n prim minus 1, Again, this is because this is the number of primitive, and by subtracting by 1 you can actually divide by the largest number the prim could be, which always starts from 0. Now now that you got the normalized value, you can then multiply it by pi, put it in the sine function, will give you a value in between 0 to 1, and then create a scale variable, which you might want to convert the 0 to 1 value into something else, like so. The target minimum value will be the outer line scale, and the maximum value, which in this case 1, will be converted into a inner curve scale. So let's say I want to scale the outer curve to 3, inner curve to 1, which might be a good idea to make it a parameter. Inner something like that. Okay, promote it. Let's make the 3, let's make it 1. Okay, now that I have a scale value, let's apply this to a constraint primitive. How do I do that? Well, you can just create a custom attributes, and later you can use it inside a vellum solver. So I'll just create a value called, I don't know, goal for now. Okay, so let's check the primitive attribute, and now you have these goals, and the maximum is 3 and the minimum is 1. Okay, so it looks like it has been applied to the outer curves to be the highest value, and the inner curve the minimum, somewhere around here. Okay, looks good. Now let's name this to set rest length scale. Later we're going to modify the rest length of the stretch value, which is this value here. This value indicates how the scale should be in the current moment on the vellum simulations. If you increase it, then it will increase the line length. And rest length original is the original length, which is initially the same as the rest length, but could be used as a reference later, because these values are not going to change during the simulations. So we could use these as a reference to scale the rest length inside the vellum solver in real time. Okay, so I think we're ready. Another things that I want to set is a obstacle, which I could first of all use a vellum solver to set a floor. So let's connect the first input here, the constraints to the second input, and the third input to here. Okay. Now, as a default, you want to set the ground position so that it will be set on top of the plane, and let's try playing it. Now you see that it jumps a little bit upward. The starting point and end point are kind of fixed, but you do see a little bit of jumps when you do a simulation. That is because of the thickness of the curve. So let's also modify the thickness of the curve so that it's more easier to guess what's the thickness. Going back to a hair and go to a stretch point, no, not really, to the geometries, and you get this thickness informations which can be set as a parameters. Let's all try to visualize it, and you see that you do see some spaces between those points when these spheres are actually a constraints bowl. Now I want to avoid the inner collisions as much as possible. I mean inner, like intersecting as much as possible, self-intersections as much as possible. So to avoid that, one way I could do is to increase the edge length to 1 so that you might be able to avoid the inner intersections as much as possible with this way. Okay, so let's see what would happen with these if I play it. Okay, still it jumps. Well, that's fine. Next thing you want to do is to kind of lower the ground so that it will not jumps. The curve won't jump. Now let's see how much it jumps. Okay, so it seems like it jumps like 0.5, which will be the half size of the thickness. 0.05 or 0.5, not 0.05 I guess, which is the half size of this length here, which should be corresponds to a constraint bowl sphere size. So let's copy this value here and going to a vellum solver, go to ground positions and say minus 0.1 minus 0.1 multiplied by 0.5 and see what happens. If I play it, hopefully this won't jump. Okay, so it looks good. It's now fixed on the same plane, 0 plane, where the y value is equal to 0. Now one other things that I want to do here is to have some pressing geometry from the top so that the curve won't go upward during the simulations. There is a chance that if the collision is too strong, the string might go upward to the positive y directions, but I want to make it sure that it only simulates on the 2D flat plane. So to make sure that happens, I'm going to create some pressing box on top of this geometry as an obstacle. So give it a box which is big enough. You could create a bounding box from the curve, then scale it up a little bit. Let's make the upward padding to 0.1. Okay, let's also padding for the X and Z, maybe a bit bigger. Let's say 5, 5, 5, and 5. Let's make this 0.5. Okay, so this is big enough, and let's also raise this value, raise this box toward y directions so that it matches with the thickness of the curve. Okay, so which should be the same as the value that I created here, except that in positive directions. So let's transform this upward without negative. and put it to the third input of the constraints. Now let's check. Going into the side view again, and you see that the top blue box and the bottom floor, you do see a in-between curve in the middle. And hopefully, okay, nothing changes. Now, I might need to raise this box a little bit afterwards, but for now it looks fine. So let's go with this for now. Okay, so in case that the curve will be a bit much bigger than the box size, then you might also want to increase the size of the box. Maybe 5 if it's a bit too small. Let's make it 10. Make sure that it's big enough. Okay, that should be enough. All right. So I think we're ready for the simulations. Let's do this. So we do have a vellum solver. So inside the vellum solver, what I want to do is to scale each of the curve by the scale value that I have set for each constraints right here. Okay, so let's do that, which is pretty easy to do. I tend to use SOP solver inside the vellum solver for ease of flexibility. Using SOP solver to control the constraints over time. Now currently the data name is set to geometry, but what I want to change is the constraint geometry, so rename this. Now if you get it into the SOP solver, what you see is the number of constraints. Then you could use a primitive wrangle to control a bunch of attributes for each constraints. In this case, I want to control the rest lengths, scale up the rest lengths over time. Okay, so let's do that. So I'm going to apply a primitive wrangle. Let's say scale by time, and filter the group by stretch so that the stretch constraints are the only one that's going to grow. Okay, now let's first get the scale value, which was named as goal, I believe. Let's check. Yeah, there you are. So this is the final scale that I want to go for. Initially the scale should be 1 so that nothing changes on the starting moment, initial state. Okay, so we want to gradually increase the scale value using time value, such as frame. In this case, the frame, you could go from the start to the end, from 1 to goal. So for the first frame you get value 1, and the end on the 240 frames you get the final scale goal. Okay, then we want to update the rest lengths by multiplying the rest lengths original, which doesn't change over time, always stay the same as the initial value, multiply by SC, scaling value. Okay, that should create a animated growing effect for each constraints. And let's check it out. Going outside the solver and let's play. There you go. Now I do see some problems that it's not pinned. Points are not pinned for whatever reason. It does do simulations, but let's see. Oh, forgot to make this pin. So you need to change the constraint type to pin to target. Forgot to do that. Okay, let's play this again. If I play it, there you go. And seems to work fine. If you look from the side view, I might want to raise the box a little bit upward. Sometimes if the box is too close, you do have some like friction to slow down the simulation, so you might want to try raising the box a little bit upward. I don't know, 0.55. Let's see if we got the difference. Not much of a difference, so maybe fine. Let's fine with 0.5. I guess seems similar, right? This part looks a bit different. Let's check again. Yeah, it looks a bit different. Maybe I do need some space. Okay, but looks fine with these. Let's check the front side. Yeah, should be fine. Okay, so let's go till the end. See what we got. So this is the final result. Now this currently is just a bunch of curves, which is not really 3D geometry. So next step is to convert this into a 3D geometry by raising up each of the curve on like y directions and loft it. Okay, now this part will need a little bit of scripting if you want to have a bit more precise results. I mean, the easiest way I could think of is to use time shift first of all to get the first frame value by changing this value to f start, and again using the time shift to get the f end value, and just raise the f end value upward. I don't know, by some 4, 3. Then create a loft between the bottom curve and the top curve, which will give you a straight lofted geometry. But since we're doing the simulations over time, sometimes the curve goes to more complex directions, and in those cases it's not really a straight lofted geometry, but you have more of a snaky like curve happening during the loft. So I would avoid using this, but instead I'm going to use a bit more complex, but more to get a better result. So the method that I'm going to use is to use trail. First of all, I'm going to get all the trail informations from the initial state to the current frame by making the trail length to at frame, which will give you a value, I mean all the collected curves from the first frame to the current frame. Initial frame, you only have one curve, so you might want to make it +1. Does that give you? No, forget about it. Let's just type frame at frame so that you get a bunch of layer informations or trail informations for each curve over time till the current frame. Now next thing I want to do is for each layers I want to create a lofted geometry from this trail. So to do that, each layer should have some unique information so that I can split these layer curves from these trail. So let's see if I already have that. Going back to where I was setting the curve. Now, I don't really have any informations for the primitive, the original geometry, so let's create some informations which I can use it to identify which curves belongs to which layer. The layer I mean here is in which positions the curve belongs to. It's on the first curve or second curve and so on. So maybe somewhere around here, I'm going to copy the primitive number to a primitive attributes. Let's call this, I don't know, PID. Any name is fine. Let's just create an ID value to each primitive. Oops. What's this? So that I can define that I know which curve is which layer. So this is a layer information. Maybe I can just call it layer. Okay. Now let's do the simulations again. These layer attributes should be kept. Ooh. What's happening? Something is wrong. Sometimes I have some problem issues with Houdini because I'm using Japanese keyboard, and when you type Japanese on Houdini you get stuck. Everything goes to hell, so do not use Japanese in Houdini. Okay, 2 byte characters, I mean. Okay, so looks good. And if I look at the primitive attributes, yeah, I do have a layer, and after using the trail, I still have these layers for each curve. Now that I have these informations, I can do a loop using those layer informations, pack all the curves which belongs to the same layer. So for each primitive, maybe not this one, but for each named primitive, let's choose this one, which gives you an option to set the piece attributes. So let's call this layer. So using this one, you can collect all the curves which shares the same attributes, in this case layer integer attributes. Okay. Now that I have these curves, it's time to raise these curves upward based on maybe the primitive number, then try lofting it to see how it looks like. Okay, let's also create a meta node like this. Now let's try raising each points on each layers upward using a primitive number, shall we? So from point, you can get the primitive number by point prims. Since it belongs to only one primitive, you can just get the first one from the array. Then I hope that this primitive, it goes from 0 to the total number of primitives. So if you normalize it, should be looking something like this, just as we did for every other wrangle. So hopefully this is a normalized value going from 0 to 1 in the outer node. And let's try to raise the y value by this t, see if it's gonna work. Now I realized that the starting curve becomes higher, and the ending curve, the outer curve, becomes lower. Okay, so I guess I need to change the order for here. I can just say 1 not minus normalized value. Okay, let's make it a bit taller. See how it looks like. Okay, now I do see some like bumps here on the layers, so these are the parts that I might want to fix later. Well, let's try creating a lofted geometry. In this case, skin might be a good idea because point number doesn't really change over time. So if I do a skin, so you get a lofted geometry, but as you can see, you have some nasty bumps on the surface, which I don't really like. I want to make it cleaner. So the next step is to how I can clean this up. Okay, I've tried, before doing this streaming, I tried a bunch of ways to try to fix this surface smoothness, get the surface smoothness, and realized using something like attribute blur doesn't really work, which I thought could be the quickest solutions. But even though if I raise this up, the whole the first problem is that the profile just changes. It does at some point it does give you a clean surface, but the surface location, the surface offset just also changes, which gives you some intersection to other layers. So that's a big problem. Even if you uncheck pin border points, you see that the surface itself is pretty changing drastically. So if you try to see it with whole curve, this curve is not that bad, but you still see these bumps, which I don't really like. So not good. So what I come up with from this curve in order to make it smoother is to try to make the initial curve, which is this one, to be more cleaner as much as possible. So what I try to do is to first of all create a perpendicular curve, which is these the line that connects these points vertically, perpendicularly. And sometimes, as you can see, there are some bumps if you try to connect these points together, somewhere around here, especially somewhere around here, which gives you a problem. These are the place which gives you the issues, a problem. So I thought that if I create a curve which connects these points perpendicularly and smooth it out using, smooth node, then recreate the contour curve from that smoothed curve, that might give you a better result. And that's what I'm going to do next. Okay, first of all, create a perpendicular curve from the current layer curves, then recreate the contour curves with maybe a less number of curves, so that you get more smooth result. So let's do that, shall we? In order to do that, I guess there are several ways to do it, but I'll just do in more of a brute force way using wrangle, in this case a detail wrangle, picking up all the points from the geometry, from the curves, and reconnect those points so that you can create a contour curve like these. Okay, so let's think about how to create a loop inside a detail record. So first of all, I want to get informations for these layers. I mean, going to the perpendicular directions. This will be 1, the next one will be 2, 3, 4, and so on. And you have that loop for over you have a bunch of points which you want to create a perpendicular curve. So these should be the first loop. So first thing I want to do is to count up how many points you have on single primitive, which does not change over every other primitives. So first pick any primitive and count up, or get the corresponding points from that primitive. Let's just get the first primitive and get the points associated with that first primitive. This will give you a bunch of primitive point numbers for a single primitive. In this case, could be the inner curve, this one, okay, which has a bunch of points, 1, 2, 3, 4, and so on. Okay, so which this variable is the one that gets that information. Now that I have that information, let's create a for loop using a count value of that array, point array. Now for each array, you want to create a bunch of points, or you want to connect bunch of points which on the perpendicular directions, and the number of that points is equal to the number of curves, number of layers. So the second loop will be counting up the number of loops, okay, number of curves. Now for each loop inside the second loop, you want to get the point array for each curve, so that you can connect each corresponding points on a perpendicular directions. So the primitive number is actually n, and if you want to get the point collections from that primitive, you can say prim points n. Okay, and then since I am on the first loop, the one that I want to pick as NPT on it, this loop is an NPTS. Wait a minute. Well, actually, this is the value, and yeah, I think so. Let me check. I am not sure if I'm doing correctly. Well, am I wrong? This is actually I, because this is coming from the primitive points, and the number of points over primitive doesn't really change, so I already have that information, which has been used as a number of iterations for the first loop. So this should be fine. Now that I have the points here, I can create a new polyline after the first loop. Then add the vertex to that polyline using this point that I found. As a result, you get a perpendicular curve which goes through from the first curve to the end curve, like a crossed curve. Now, in order to smooth out these curves, I don't really need those original curves anymore, so let's delete that as well. Which I can do it. Where should I wait? I could do it here, I guess. I mean, you could create another loop, but doesn't really make any changes. All these remove primitive doesn't activate immediately, it just activates after everything is being created, so it's not a problem deleting it here. So something like that. All right. now I only have a cross-section curve, and I do see some bumps here and there, which is the cause of these dirty like sections. So next thing I want to do is to clean these up a little bit. Okay, so let's name this perpendicular curves. Okay, then next I'm going to, first of all, currently the point number is a bit too large for each primitive, so let's reduce that, which is also necessary in order to smooth out in small iterations. So without using segment lengths, I'm going to set a number of segments instead, so that you can have the same number of points for each curve, which is necessary in order to later recreate a layer curve from this perpendicular curve. Okay, now let's also set a subdivision or interpolation. Is it changing? I don't know. Not so much. And let's give a smooth. I'm not sure what's the best value for the smoothness. Let's make it like the highest for now. Might go back here to change the value. Let's set the strength to 50. So now if you compare this geometries to the original contour geometry that I have, you do see some cleanness in here. Now let's make this back to a original layered curve, which looks like these with less number of curves. So what I'm gonna do is similar to what I have already done here. Okay, so I'm gonna copy this, change this to Hori curve, and if you connect it, you'll just get the same result. I mean, you can just get the transposed curve as a result, which looks fine, I guess. Okay, I do see some like low res result here, which is already happening here, so I cannot do anything for that. I mean, you could resample after this if you want. Let's try just going with this for now. You might want to still use resample in order to create a UV value for the later process. So let's give a resample node without dividing the curve, but just giving a curve view value, which gives you a value in between 0 to 1 from start to the end. Okay, now that I have all the informations gathered, let's try to raise the curve just as I did here and see what happens. Connect it here, create a skin. You see that the geometry is much cleaner now Okay, let's leave the loop and see if we have any problem, and looks pretty nice. All right. Okay, so far so good. The next step is to set some UV to this surface so that you could do some trimming from the start point to the end point like a mountain shape to achieve something like this profile. Okay, so setting UV is not that hard. Let's go back to where should we go? First of all, curve U can be used as a U value for the UV, and then everything else you need, all the rest you need is the V value, which is the height value, which can be applied here, I guess. So let's go back to this point wrangle. Now I have this T value, which corresponds as the height informations. Now you do have a final height value here. Let's make this parameterized so that you can control it later. Now, so I want to convert this T into a V value and using curve U as a U value for the UV, which is pretty simple. Just bring up the curve U as a U value and T as a V value, 0 for the W. And you get this clean UV result. Okay, nice. Then if you leave the loop, every curve, every surface will have these UV in the same manner. Okay, final step, trimming. So in order to trim from this first point to the end point like a mountain shape, the easiest way I found out is to use clip node. Okay, clip itself just gives you cross sections like these, but by modifying the original point positions based on the UV value, in this case a V value, I guess, or U value, I guess, because U value is from start point to the end point informations. So using that informations to oops, sorry, is it still streaming? Okay, I don't know, my display just went black. Hopefully it's fine. Okay, so what I wanted to do is to combine this clip with some point modifications in order to clip so that you can clip it from the first point to the end point. Well, so let's try doing that, shall we? So what I need to do, first of all, remember the current point positions by using rest node, and then using point wrangle to modify the point positions. In this case, I can just change the height Y value, and since I'm going to trim it by like a mountain like shape, again I can use sine or cosine in order to trim. Okay, so let's try that. First of all, the U value is v at uv.x, which goes from 0 to 1 from start point to the end point and start side to the end side. Then let's use sine function for this U multiply by pi, which will give you a value in between 0 to 1. Okay, then I might want to get the informations about the total height of this geometry, which you could get using the size get bbox size, meaning bounding box size, which gives you the bounding box size for the input in the first input, and the y coordinate of this size is the height of this geometry. So considering that, what I'm going to do is to subtract the current y direction, current y coordinate by a size dot y, the total size of the height, which just brings the whole geometry beneath the floor. And what I would do next is to multiply by t, which raises the starting point, starting side. You see that the starting size is kept on the floor, then gradually going underneath like this. Okay. Now, by doing this and using the clip after this, clipping using a -1 to the y directions, you get the geometry like this, just getting the underneath geometry. And if you use another rest position to restore the original points, somehow you get a mountain-like shape clipped from the original geometry. Okay, so this is one of the trick you could use to achieve something like this. And since I'm only using u value for this step, maybe I didn't really need the uv, but I just needed the curve u. Well, anyway, could be useful for rendering. I mean, uv is still useful for the rendering, so let's just keep it. So looks fine. I mean, you could also control the shape of this trimming without using sine, but instead, I don't know, using something like ramp parameters and so on. Or you could apply some power functions after the sine to have a bit of controls over this. Or make it 0.5 and so on. So it could be additional parameter. Okay, should be okay from 0 to 2. See? Maybe from 0.5 to 2 is fine. Good. But I'll go with 1 for now. Okay, so looks all good at this point, and I am already at the end of the result. All you need to do now is to have some coloring and visualization set up, and that's all. I'll use a normal to recalculate the normal directions for the surface. And in order to set the front side and the back side of this plane with the different colors, I will let me try cleaning this a little, see if I can reduce the number of unnecessary points. Nothing changes, maybe not necessary. Okay. I could create a poly extrude. Extrude is a little bit to the outward. 0.01. I don't really need the side. Let's give a backside as well. Give different group for the front and the back. Let's hide the UV. And let's color different color for front and the back to see the result better. Set this to primitive, set this to front. Okay, let's set the front to white and set the backside to darker colors. There you go. Now I do see some touching here. Where's this coming from? Might need to increase the offset a little bit more. Okay, so like that. And I don't know, maybe you can apply some environment light using some HDRI image. Let's hide the background. A bit too shiny. Let's also create some material for this one. Principal shader. Make it white. Material. And apply that principal shader. It's a bit too reflective. I would want to reduce that. Give some roughness to it. Kind of looks different to what I did previously, but anyway. In the end, you might want to just use chroma for the final rendering. Okay. Anyway, that looks fine. And you get the result like this. So, which could be, now I might want to set some animation setup for this one. The starting point starting from here looks a bit weird because it's already have some height here. Just spreading is fine, but starting with the final height looks weird, so let's fix that. And the first frame doesn't have anything, so that's also not cool. So let's go back to this loop and try to fix some stuff here. In this case, trying to fix the height. So in the first frame, you only have one curve, so it's not possible to create any height. So let's create additional curve so that you always have minimum 2 curves to be able to set the height, minimum height. I'm just going to, since this is where I'm setting the height here, I'm going to transform or translate the curve after the resample to a negative directions just a little bit, and let's just pick the first curve, shall we? There's a possibility that I have many curves here, so let's just get a first curve, delete non-selected, and just move it downward a little bit, then merge it and apply some UV and height to that curve. Now, initially the height should be really small and gradually increase the height based on the timeline. So let's also fix that. So currently I'm just using the height as it is for the final height, but I could apply some frame-based value, which in this case I can fit the frame from start to end from 0 to 1, normalize the value from 0 to 1, and multiply it here. Now if the value is 0, nothing can be seen, so maybe I can increase the initial f value a little bit, 0.01, like that. Okay, so let's see what would happen here if I play it. You can see that the height gradually raised up and now, and should be trimmed here. I don't really like the reflection here, do I? It's a bit hard to see. Let's go back to environmental light. Let's just go with this. And you go. Now you have a growing curve. Okay, so let's go back to where I was referencing to. And one thing that I noticed that the height of the curve for each layers is a bit different to make a bit more organic. You see that the curve right here is a bit smaller. The one that on the outside is a bit taller, seems like. So might be a good idea to also control the height of each layers based on, I don't know, the primitive numbers from outer to inner curve. Okay, so let's also apply that rule somewhere. And that could be done where I am controlling the trimming for the y value. So let's have that function right here, shall we? Now, in the examples that I see on the Pinterest, the outer curve looks higher, the inner curve looks smaller. So again, let's use some kind of a trigonometry to have that kind of value. In this case, I'm going to use cosine and with 2 pi as a parameter, so that you get more like a wavy value, more like a hill-like value, going from the 1 to -1 to again to 1. Okay, so to do that, where should I have it? Let's write some code here. So first thing first, let's get the number of primitives, which in this case, this is not already a curve, it's already a geometry, I mean a surface, which has a bunch of primitives. So I need an information like this layer, but the layer has all been set to 0. So at some point the layer has been destroyed, maybe when you have done a skin right here. So before using the skin, did I have a layer? No, not anymore. Resample. Well, I guess I do, right? You can check it by single path. If I set it to single 1 and check the curve. Well, I guess not. where does this layer been deleted? So I still have the layer here. I should be having layer informations here, because that's what I'm using to filter. So I should be having it. Why am I not seeing it? Huh. Wait a minute. That is because I have recreated the primitive right here, so I think I have to transfer the layers from the initial input of the for loop and transfer it to a skin. Okay, so let's do that. I will just use a primitive wrangle to transfer the attributes. I mean, there are node called attribute transfer, but sometimes it doesn't really work because it's based on the position of the reference. So instead, I'm going to use the safer way, using wrangle. So the layer information's coming from the second input, which is always the same for each iterations, and then copy it to a primitive. Okay, there you go. You might want to have that same informations to a point, so also let's copy that to a point using attribute promote. From primitive to point, copy the layer, don't delete the original, and you get the same layer attribute to a point. Okay, now that should be useful informations. Additional as an additional informations, what you would want is the total number of curves, total number of layers, which has been defined here, this 10. So maybe I can just copy it. Okay, let's go back to here and let's have that information. The number of curves can be 10 in this case. And you have a layer informations on the point wrangle. Yeah. Now let's normalize this layer value using the number of curves, just as we did in any other examples. Normalizing is pretty important here. So let's name this L, layer divided by n curves minus 1.0. The reason why I'm using 1.0 for the minus is to make sure that this is float number. If I set it to 1, it will become integer. So what you get as a result is a round up number, either 0 or 1. So you don't want that. You want to have graduate float numbers. So that's the reason why I'm using 1.0 here. Okay. So this is a normalized number from the outer curve to the inner curve. It's uncheck single pass. Okay. Then the next things you want to do is to create some height informations from the inner curve to the outer curve. Okay. So for that, I am going to use a cosine and multiply L by, starting with pi multiplied by 2, okay, which is 360 degrees, going from 1 to -1 to 1. Okay, and remap that value to, let's say, the outer curve. Let's set the scale to 1 the inner curve, let's set the scale to 0.25, make it smaller, make the height smaller. So let's name the variable LSC, and finally I'll try to multiply this LSC to the height and see what happens. Now what I see here is the inner curve become higher and the outer curve becomes smaller, which is not really what I wanted, I guess. The other way around. So could be 0.25 or 1. There you go. Well, it's not bad, but maybe the outer curve is a bit too big from what I see here. Maybe it's more like a two-shaped mountain. So the most outer curve will be smaller, then becomes bigger, then smaller, and then becomes bigger, and so on. So let's make the number of wave two waves, and let's set this to 1 again, set this to 0.25 again, and oops, I now have some similar result like this. Looks good, looks better. Now this could be parameterized as well. How do I name this? Min scale. Looks good. And let's also set this to max scale, so that you can control a bunch of shapes. Yeah, and maybe you might also want to control the number of waves here, so wave number could be interesting. I'll go with 2. And what else? That's pretty much it. Height, maybe. Where am I controlling the height? Actually, I don't have it here. I mean, I don't really need that, do I? Because I already have the height informations inside this loop. Okay, so that's good. The camera is a little bit weird. Let's fix that. Okay. Okay, so overall looks good. Let's go to the final step, and yeah, let's clean it off. Now that I have a basic setup, I can now explore all sorts of geometries using the setup I here. Now to do that, it's a good idea to organize the parameters so that I can come back to the same place to control all the options I have here. So I'm going to create a null node where you can control a bunch of parameters in one place. Okay, so okay, let's open up the parameter interface. Let's start with the length, the resample length. Which can be seen as a resolutions for the curve. And copy that value wherever you need it. You might want to use the same resample inside offset, because after you do the offset, the length changes a bit, so might be a good idea to resample this after you do offset to give you a little bit. Oops, I think I need to reset the simulations. Okay, yeah, better now. All right, so next parameters. So automatic is fine. Offset, okay. The value offset. Let's call this layer offset. Okay, and you also want to control the number of layers, so layer number, and this is automatic. Let's rename this to layer. It's automatic. Now I might want to change the stiffness as a parameter to see how it changes. So let's bring this right here, call this bend stiffness. Might get something interesting if I change the bending stiffness. Okay, this is also important. Outer curve scale. Inner curve scale. That's all for this one. And do we have anything to control inside the solver? I don't think so. Oops, just fit. I don't think it's fine. This is also fine. Perpendicular. Now, the number of segments could be controlled to control the final resolution. So how do I call this? Loft segments. Okay, actually I'm using skin instead of loft, but it's fine. Okay, this is automatic. Calculating the curve view. It's fine. Okay, height. Loft height. Okay, and using skin transfer attributes is automatic. Blah blah. Rest. Okay, trim Y. A bunch of parameters. What was this? Power for controlling the mountain shape. How do I call this? It's not, cannot, shape. And min scale, I'll just call shape min scale. Might be hard to imagine what it really does, but let's just go with this for now. Max shape max scale, shape max scale, and wave number shape wave okay. Then we have clip, rest, normal, poly extrude. This is fine. Color and material. Okay. Not really related to the modeling, so I'm just gonna skip material like that, parameterizing it. Okay, so I have a bunch of parameters ready. Let's try playing out with all the different parameters. Now, first drastic change that I could think of is changing the stiffness of the simulations. So let's try to change the simulations stiffness, bending stiffness. Let me go to a window cache manager, increase the cache for the vellum just in case, and let's go to all the parameters that I have here. So currently the bend stiffness is 1, actually multiplied by 0.1. So what happens if I set to 10? So the curve should become a bit more harder. And at some point I do see some inner intersections which isn't optimal, which is not really good, but let's see the result. Okay, not much change happening. Okay, so 0.1, I mean 1 and 10 doesn't really give any much change here. Let's change this to 0.1 instead, not this. Stiffness to 0.1. Yeah, I'll just skip to the last result. And yeah, start to give you some interesting result. You have more bendings because of the low stiffness, and get kind of interesting result here. Now let's set the stiffness to 0.5, make the number of layers to 20, and what else? Let's go with this for now. I can change the other parameters later. Let's wait till the end. And okay, I see some issues here, probably due to how I create the loft geometries. Okay, so in this case I could try increasing the segments right here to increase the resolutions. Set it to 20, 50. Doesn't really get result. Okay, one other things that I could try. Let's make this back to 10 and set the inner curve scale a little bit bigger, like 1.5. Currently 1 is maybe a bit small, too small, meaning it doesn't really change for the inner curve. So let's give a curve a chance to move around with higher value. And it still gives you intersections, but a little bit better than before, because inner curve is also changing its shape. Okay, and maybe I could also make the layer offset a little bit bigger, like 1. Oops. Recalculate the final result. Okay, and yeah, starting to look better. Okay, now after that you could also change these shape, min, scale, or number of like layers and number of waves, total height, to see a different like shape. Okay, it's pretty fun. And you could also, of course, you could change the initial profile curve. Let's give another shape a try. Let's move around this curve to see a different result. Something like that. I don't know. Looks like 3 is a number. Or maybe more like this. Oops. Okay. Let's go with this. And see what happens. Let's check the vellum. Alright. Interesting. And what if I change the stiffness to 1 bit more harder? The harder you have, more chance that you get inner intersections, so you might want to be careful. I mean, these could be fixed by also having some offset distance between the curve as well, so you might also want to control that as well. I don't know, maybe 0.5 was better. Let's go till the end. Okay, looks fun. And let's go to the end, see the result. Maybe the number of curves a bit too much. Let's give it 6. So looks like this. And yeah, that's pretty much it. I mean, you can try playing out with this with many other parameters and should be getting a bit different result. Right, so I guess this is the end. Let me know if you have any feedback or comments till this step. I'll try to answer any questions as much as possible. If not, I'll end the live stream for today. Okay, if anybody's here. Alright, well, maybe. I think I don't have any questions, so shall we just end this? So if anybody's here, thank you for listening. Thank you for watching. As always, I'm going to upload the files and you can download for Patreon page that I have for free. I'm going to paste the link to this YouTube video link later so that you can download a file for this. And yeah, if you feel like I don't know, donating, then that's also great, you know, on Patreon. But not really necessary if you feel like it. Okay, so that's it. Thank you very much for listening, watching. I will try to create something else next week as well with different topic that I found interesting. Okay, so hopefully you'll be there as well. Thank you for all the comments, and good night. Let me just create some animations and end this live. I'll give, since the simulation is a bit slow, I mean in terms of creating the geometry part is a bit slow, so I need a file cache here for the final animation. And save this. Okay, I tried to do a sketch using an iPad, but it didn't really work, so maybe next time. Oh, happy birthday, Monica. Thank you for watching it on that important day. Okay. Well, just a little comment on this setup. Firstly, I wanted to use a surface-based vellum simulations, but didn't really work because I needed to gradually increase the shape. I mean, remesh the shape over time, which created kind of a messy geometry in the end, which wasn't really clean. So there should be some way to do that, but maybe that's for next time. I need to make a clean setup for that. So for this one, I just use the curve simulations, but still seems to work fine, just if you just want to create the final geometry like this one. But in the end, it will be more flexible if I can use a surface-based physics. So that's my next goal related to this, I guess. Hopefully I'll be able to do that. And if anybody has some idea how to like remesh over time with the clean surface, I'm all ears. All right. Come on. I'm gonna finish this live with the final animation. Okay, well, I'm kind of wondering what to do for the next live stream. I don't have much idea yet. I had some ideas from last streams to create some architectural geometry like buildings or bridges. Could be an interesting topic for the next one, maybe. Okay, almost there. Alright, if I play it, no glitching, looks green. Cool. Now I realize that I might want to control the speed of the growth differently for each layers, but maybe that's up to you guys. Okay, that's it for today. Thank you very much for watching, and good night. See you next week.